Let's see the next topic in general science, that is Newton's law of motion in mechanics. In mechanics, this is one of the important topic which is commonly asked in the exam. And in exam, he can ask you about the inertia and its type, the example of inertia. The next one is Newton's law of motion. So there are three Newton's law of motion from which he can ask you anything. Okay. And afterward, it is the example of Newton's law of motion. So there are three laws. So which law is relevant to which example, that you should be very thorough in this concept. Okay. So let's see the first question. Philosophy Naturae Principia Mathematica, which is also known as Principia, published in 1687, is a great work of which scientist? Basically, this is the book which is written by Sir Isaac Newton, okay, which has these three Newton's law. Okay, so this book has these three Newton's law of motion, which was published by the great scientist Isaac Newton. Okay, so option D is the right answer. And we have seen in our theory class that these are the important pointers which are generally asked in the exam. The first one is that it is basically a physical law which tells the relationship between motion of object and force acting on it. Okay, previously there were many people who give some theory, but this is the book which basically give the mathematical concept behind all those relationships. Okay, and it is also known as Newtonian mechanics, and it is first stated by Sir Isaac Newton in this book in year 1687. Okay, that is basically a factual question. So in 1687 this book was published, Philosophy Naturalis Principia Mathematica, which means mathematical principle of natural philosophy. Okay, so this book is written by Sir Isaac Newton. Okay, and the very important thing about Newton's law of motion, that it is not applicable to those objects which are very high speed, that is at the near speed of light. Okay, for this the theory of relativity come into picture. Okay, similarly, this Newton's law of motion is not applicable to the atomic particle, for which quantum mechanics have all the answer for the motion of atomic particles. Okay, so remember, it is not applicable to those objects which are at very high speed. Okay, Newton's law do not hold good for particle at rest, moving slowly, moving with high velocity, move with velocity compared to velocity of light. So as I told you just now, Newton's law does not hold good for the particles which are nearly comparable to the velocity of light. Okay, so option D, those who have given, they are right. Among which of the following is the maximum value of inertia? Okay, option A, same size of rubber ball and stone, scooter and bus, 10 rupees coin and 5 rupees coin, trains and aeroplane. Okay, so you need to tell which is going to have maximum value of inertia. Student, inertia, as you know, inertia is basically, you can say it is a tendency of an object, okay, which can be in a state of rest or in the state of motion. And we have seen in our theory classes that mass is a measure of inertia. So here if you compare in all the option, the trains and aeroplanes have more mass, so this is going to have the maximum value of inertia. Okay, so option D is the right answer. And in the theory chapter we have seen that inertia is basically the property of body which oppose any change. Okay, oppose any change in terms of what, that if it is at rest, it is going to be at rest, it is in motion, it is going to be in motion. Okay, and this is very important. The mass is the measure of inertia. Okay, higher the mass, higher will be the inertia, lower the mass, lower will be the inertia. And there are three types of inertia: inertia of rest, inertia of motion, and the inertia of direction. What does the inertia of rest means? That a body resists the change from rest to motion. Okay, the perfect example is that passenger fall backward when bus start suddenly. Okay, so this happen because you are at rest and your upper body start moving, so that's why it is going to fall backward. Okay, since it opposes the change, body opposes the change from what? From rest position. Okay, similarly the dust come out from the carpet if written, coin flipping, card on the glass. So all such examples are the inertia of rest. And similarly, if a body is in motion, it try to remain in the motion. Okay, and it is going to resist stopping. Again, if you take the bus example, the passenger will fall forward when bus stops suddenly. Okay, so if bus is there, okay, and it is going, so your lower body is still moving, but your upper body is getting jerked because of this resist in change. Okay, similarly inertia of direction. So suppose that bus is moving sideways very sharply, so body is going to change, resist the change in direction, so they are going to fall the sideways. Okay, so these are the three types of inertia. Which of the following statement is false? When a bus stops suddenly, a passenger sitting in the bus is jerked backward. This itself is false. Why it is false? When bus stops suddenly, the passenger sitting in the bus will be forward, not backward. Will be forward. Okay, so option A is the right answer. This is incorrect. Okay, just now we see that when a bus stops suddenly, it means that it is going to resist the motion, so that is inertia of motion, so because of which the passengers fall forward. Which law of Newton's provide quantitative definition of force? So as I told you, there are three laws of motion, Newton's law of motion, and it is the second law of motion which give the definition of force that we have seen in the previous chapter, that is F is equal to ma. Okay, so let's quickly glance over the three laws of motion that we have studied in theory class. I know all of you know very well regarding these laws. The first one is first law of inertia. So it is basically the definition of inertia. A body at rest will remain at rest, and a body in motion will in motion unless it is acted by some external force. The example just now we have seen, the example of inertia, these are going to be the same example for the law of inertia or the first law of motion. Okay, the second law of motion, the change of motion of an object is proportional to the force impressed in the made of direction in the straight line in which force is applied. So it is basically F equal to ma and F is equal to dp by dt, where p is a momentum, p is equal to mv, momentum is mass into velocity. So what does it say is that if you want to make a change, you need to impress a force proportional to it. Okay, example is if you want to push a cart, kick a ball, and hit a cricket ball. So all such examples are the examples of second law of motion. What about the third law? Third law, a very simple one. To every action there is an equal and opposite reaction. So F12 is equal to minus F21. The common example, the best example is rocket launch. It is basically the third law and the conservation of mass. Okay, so to every action there is an equal and opposite reaction. A ball on the wall collide and return. So if you throw a ball and it is returning back, it means it is a third law, because the ball is force with which it hits the wall. Wall is also hitting in the same force. Sailor jumps in the forward direction and boat drifts backward. Gun recoil, walking, swimming, all such examples are the examples of third law of motion. Okay, so the next question, what is the equation of Newton's second law of motion? There are two equation. The first one is F equal to ma, the second one is F is equal to dp by dt. Okay, and if you solve it, P is mv, so dt mv, so m is constant, so you are taking it out. dv by dt is what? It is change in acceleration, change in velocity by time, that is acceleration. F is equal to ma. Okay, either F is equal to dp by dt or F is equal to ma, both are the same. Why does cannon recoil after firing? So since a cannon is like this, okay, so a cannon, if it fires, so it is having the backward similar force in the opposite direction. So it is the Newton's third law of motion: to every action there is an equal and opposite reaction. Okay, so after firing, the opposing force will also act in the opposite direction. Why does a fielder turn his arm backward while catching fast approaching cricket ball? This is basically the concept of impulse force. Okay, impulse force is what it is represented by J. It is force into T. Okay, impulse is force into time. So since he is moving his arm backward, so basically he is giving time to reduce the momentum. Okay, so that's why, so that he does not get hit, because it is going to have a less force. Okay, so because he experienced less force over a long period of time, basically it is nothing but the impulse, so that's why he is putting his arm backward. Okay.